Hey everybody, in this video we are going to solve a system of equations by substitution. In order to do that, our first step is going to be to solve one equation for one variable. Now in this case, that's already done. This first equation is solved for x. So we just want to get one variable by itself, and that is done. So we can actually move straight to step 2. Substitute into the other equation and solve. So this value of x, I'm going to substitute right here into the other equation for x and solve. So that's 5 times x, and x becomes 3 minus y, plus 3y equals 5. And now I can solve this equation for y. So I'll distribute and get 15 minus 5y plus 3y equals 5. Okay, now I'm going to subtract this 15 from both sides. And I'll also combine these like terms. Negative 5y plus 3y is negative 2y. And 5 minus 15 is negative 10. And I will divide by negative 2. And find that y is 5. Okay, so I've got y is 5. And then I move on to the next step, plug in and solve for the other variable. So I take this value and I plug it into either one of these two equations to solve for the other variable. The top one looks easiest, so I'll go with that one. X equals 3 minus y, and y is 5. So x equals negative 2. So I'm saying that these two lines, if I graphed them, would intersect at the point negative 2, 5. So that is my solution. Now, let's just check that. So negative 2 equals 3 minus 5. That is true. How about here? 5 times negative 2, that's negative 10, plus 3 times 5, which is 15. Negative 10 plus 15 equals 5. That is true. So that means that my solution here, negative 2, 5, is correct. Okay, now on number 2, there is not a variable that is by itself. So how about we'll take this bottom equation and solve it for x. So I'm going to move this over and get 2x equals negative 6y minus 1. And if I divide everything by 2, I get x equals negative 3y minus 1/2. Okay, so I have solved the second equation for x. I'm going to take this value of x and substitute it right there into the other equation. So that's 3 times negative 3y minus 1/2 plus 4y equals 6. Okay, now I'll distribute negative 9y, and then 3 times negative 1/2 is negative 3/2 plus 4y equals 6. Okay, so we'll add this 3/2 to both sides and combine our like terms. Negative 9y plus 4y is negative 5y. And then 6 plus 3/2. 6 plus 3/2 is the same as 12/2. Okay, so 6 is the same as 12 divided by 2, right? So 12 divided by 2 is 6. 12/2 plus 3/2 is 15/2. Then I can divide both sides by 5. And that's the same as 5 over 1. Okay, so when I divide 15/2 by 5 over 1, let's do this. This outer loop, 15 times 1. And I know it's going to be negative because it's positive divided by negative. So I'll put that negative here. 15 times 1 is 15. And 2 times 5, that's going to be our denominator. That's 10. And that's going to simplify. Negative 15/2, or negative 15/10. 5 will go into both of those 3 times and 2 times, so that's negative 3/2. So I've got y is negative 3/2. Now I have to decide if I want to plug that into the first or second equation, and I think I'm going to go with the first equation. So I've got 3x plus 4 times negative 3 halves. Negative 3 over 2 equals 6. Okay, now positive times negative is negative. 4 times 3 over 2. 4 times 3 is 12. Divided by 2 is 6. And now I'll add 6 to both sides. 3x equals 12. And divide by 3, so x is 4. So my solution is 4 negative 3 halves. Okay, so it's always a good idea to plug those in. 4 times 3, or 3 times 4 is 12. 4 times negative 3 halves. 4 times negative, that's going to be minus. 4 times 3 is 12, divided by 2 is 6. 12 minus 6 is 6. That is true, so I know that it works in the first equation. 2 times 4 is 8, and then 6 times negative 3 halves, that's going to be negative. 6 times 3 is 18, divided by 2 is 9. 8 minus 9 is negative 1. That is also true. So I know that my solution is correct. Number 3. This one is solved for y. So we get to skip step 1 and go on to step 2, substituting for y. X plus 2 times negative 1/2 x plus 1 equals 4. So I can distribute. X plus 2 times negative 1/2 is negative 1, so negative 1x. And then plus, that's supposed to say plus 1. 2 times 1 is 2 equals 4. And look at this, x plus negative x, those cancel each other out. So I get 2 equals 4. But I know 2 does not equal 4. That is not a true statement. When all the variables just disappear like this and we get a false statement, we would say no solution. These are parallel lines. They do not intersect. So there is no solution. Now what if we were to have gotten 4 equals 4? So all the variables went away and we got a true statement, 4 equals 4. That's a case where we would say the lines are one line right on top of the other, and there's an infinite number of solutions.